Yeah.
Okay. Come on in, Desiree. We gotta get started quickly. Phone up, please.
Man, two binomials. What's a trinomial?
So a binomial has how many terms?
Two. Trinomial has three. And what's the first one?
What are y'all talking
What's the first
about?
one? It's trinomial, binomial. I forgot the first one.
Monomial.
Come on.
What are y'all talking about?
Monomial?
Is that math?
See, reason I would know that because I had to go to ingenuity. That's why.
One term is a monomial. You know how like Judaism, Christianity, and Islam are all monotheistic religions?
Yeah.
Mono meaning one. So when you have one term, it is a monomial.
My church is a denominational.
That means you don't have
Where?
Non-denominational?
Yeah, that.
Means that you don't ascribe to being Baptist or Methodist or Episcopalian or any of that stuff. That's different.
Oh.
Wait, is that in COH?
Monotheistic.
Yeah,
What's behind?
yeah.
Yeah. Monotheistic just means you worship one God.
Okay.
So monomial, binomial is two terms, trinomial is three. Okay, any questions though on this before we get started? Because again, problems just like these three and the three that you have like this tonight for tonight's homework will be on your test on Wednesday, so we need to make sure we know how to do this.
I know. I still know how to do it.
Huh?
I know how to do it.
You do know how to do it?
Yeah, because I told you I had to go to ingenuity and explain all this.
Just making sure.
It took a long time.
Wait, where did the plus 4x come from?
This one?
Yeah.
You multiply.
Where?
You multiply.
So remember, we're taking negative 2x plus 2, that binomial, and multiplying by negative 3x minus 5, right?
Yes.
So what does negative 2x need to be multiplied by?
Negative 3x.
Just the negative
And
3x?
5.
Oh, and the 5.
So negative, it needs to be multiplied by the entire negative 3x minus 5.
Oh, okay.
What does this plus 2 need to be multiplied by?
Negative 3x and 5.
I don't know.
Negative 3x and 5.
Not just 5, negative 3x minus 5.
Oh, my fault.
It needs to be multiplied by this entire thing.
Oh, okay.
So each term of the first binomial is being multiplied by each term of the second binomial, okay? And so negative 2x times negative 3x, remember that's positive 6x squared.
Yeah.
Negative 2x times negative 5.
I don't know.
What's 2 times 5?
10.
10.
Negative 10.
But it's a negative times a negative.
Oh, positive 10.
So it'd be adding 10,
X.
there we go.
Uh-huh.
And then 2 times negative 3x,
6x.
adding or subtracting.
I don't know. Subtracting.
Why?
Because I'm just guessing.
Well, what's a positive times a negative?
I don't know. A positive? I mean a negative? A negative.
Raise your hand if you think a positive times a negative is a negative.
You said what?
Positive times a negative is a negative.
It depends what a positive and it depends what a negative is. Right?
It depends.
What? It depends if a higher, like it was a high positive like 19 minus like negative 2. And then,
Oh yeah, adding and subtracting?
No.
What are we doing?
Subtracting the negative.
I think
What?
minus. Minus.
Oh.
Oh, that's why.
So negative, negative,
What? You multiplying what?
a positive times a negative.
A negative?
Negative, Desiree? Negative, Devin? Positive times a negative is a negative, Layla? Okay, so we're all in agreement, negative? Okay.
Yeah.
So then because it's a negative, it'd be minus 6x.
Minus, yeah.
And then 2 times negative 5 is
10, negative 10.
negative 10. Notice, what is 10x minus 6x?
Oh, 4x.
4x.
Okay,
Okay.
I got it.
As a quick reminder of terms, so Corell already brought up monomial, binomial, trinomial, but I also want you to remember this. If it's a 6x squared, what type of term is that?
Geometric. I'm just kidding.
Geometric?
Yeah.
Raise
No,
to the
wait.
second.
Wait,
Oh,
no, I
quadratic.
meant to say quadratic.
It's It's quadratic because it's raised to the second?
Yeah, I meant to say quadratic.
Layla, you agree with that idea? Okay. So we got a quadratic term here. X to the first would be,
Well, x to the first. Oh, okay. That would be
exponential, my fault.
exponential, linear,
exponential.
exponential,
Which one's multiply?
linear.
Which one's multiply?
What do you mean?
Which one has to multiply? My fault.
Like repeated multiplication?
No, which one has the multiplication rate change? That's just exponential, ain't
Right, when the variable is in the exponent.
it? Exponential.
So this is exponential, 4 times x to the first.
Quadratic, because it still raised to, I don't know. I really don't know.
Okay. Desiree, can you tell us what type, quadratic is when the power is what?
Raised to second.
2. So if this is not raised to the second, is it quadratic?
No, that's what I said. No, I don't know. So is it exponential? You should know, you the teacher.
I should know. So Desiree's thinking linear. Why do you think it's linear?
Wait,
Shelby said so she must be right, right?
well, repeated, repeatedly adding.
Okay, let me ask this, Shelby, when is it exponential? What should it look like?
The variable should be.
The variable should be in the exponent.
Yeah, I know that.
Oh,
So is this exponential?
no,
What is it? Linear?
it's, mx plus b.
Slow? Slow?
Oh, it's
Point slope.
So if it's x to the first, it is
linear.
linear. So quadratic, linear.
And regular whole number,
constant.
constant.
No variable means it's a constant, because
Oh.
it cannot change or anything like that. Does that help clarify some things?
My stomach hurts,
I'm sorry.
and I feel sick.
That's not good.
What if she gets sick and I get sick? I get out of school. Yes.
Really quickly, I do want you to notice when it was a linear times a linear, it became.
Huh?
When it was a linear expression times a linear expression, it became a.
Quadratic.
Quadratic.
Raised to second power.
Same thing here, right?
Yes.
Was I multiplying linear expressions here though?
No.
What was I doing?
You multiplying. Adding.
Adding them, and it stayed what?
But you wasn't multiplying. What you mean? Second power. The two.
On number 3,
You was carrying the two times.
distributing.
Distributing, yeah.
But notice what's 2 times 2x?
6x. 4.
For
Raised.
what?
4x. My
Thank you. And then 2 times 3 is.
6.
But notice, am I multiplying the linear expressions?
Oh no, never.
I'm adding them, right?
Yeah.
When I add and subtract linear expressions, it stays
Same.
the same. Linear. What is that?
That's your line.
Oh, I must have accidentally snoozed it when had that set up to start. Okay, really quickly, if you are ready to turn in this review homework problem, go ahead and turn it in. Otherwise, if you need to take some notes to help you complete this,
No.
you can do that.
Gosh, I shouldn't be right.
Why weren't you taking notes earlier?
I was too focused to the group work.
I'll help you with it during enrichment, okay?
I'm not do it.
Okay.
But I just need like justification for whatever you're gonna say for me.
Okay, so I'll help you with that during enrichment. Buckets. Alright. Is anybody ready to turn in these problems, or do we all need a little bit of help?
Oh.
Okay. So I will not have a late penalty for you tomorrow if you need to take these notes. What you got, Earl?
Oh, never mind. You just said. I remember I said I left my binder. It was here on the desk.
So yeah, I will not have, you're lucky then, there's no late penalty if you need to take notes. If you are ready to turn this in now, then you can get a bonus for going ahead and turning it in today.
No what?
Turn my name
A
for me.
bonus.
Can you turn my name for me?
That's it.
Correll, am I punishing you for turning it in late?
But you're not giving me the bonus points for turning it in on time.
You're right. Why would I give you bonus points for turning it in on time? I'm giving bonus to the people who were ready to turn it in the day it was actually supposed to be due because they did it over the weekend.
I left my
I
binder.
want to
It's
turn
your
my
fault.
name.
I had the excuse.
I want to turn my name, but I don't feel like doing it.
She ain't justified, Miss Kim. No justification. She has to redo it.
I would take some notes.
Dang. Hell.
Okay. One quick thing I do want to make a note of. Moving forward, if you turn assignments in late,
You get.
you cannot do an improve and resubmit.
What?
Only if you turn things on time, and on time, can you get the improve and resubmit. Why are you looking at me like that? Get it done on time.
So you telling me I do my homework, but it's not fully done because I may miss like one question or two questions for homework. And then if I don't turn it on time because I'm trying to finish it in enrichment, you would take.
If you turn it in day of, you're fine.
Not to,
But if you turn it in a day late, you do not get the chance to improve and resubmit.
So you saying I got a question though. So if I do like half of the page, I turn it in on time. Can I still resubmit it or no?
Not the problems that you didn't try.
Okay, that makes sense.
Can you
Yes.
give me a tissue, please?
She's 6'6".
Should I just leave the tissues back there next to you?
Yes.
All right, we need to move quickly through this now. Really, now one thing I do want you to remember is before you start trying to create recursive or explicit equations, you need to identify what about those functions.
What?
What do you need to recognize about the type of function, or about the function, before you start trying to create equations?
The type of.
What type of function it is, thank you. So when we look at number one, what type of function are we looking at?
Quadratic.
Not
Exponential.
linear and not quadratic.
Yeah, there's no parabola there, that's an exponential curve. So we want to recognize that it's an exponential function, meaning it has what type of rate of change?
Linear.
Repeated
Oh, yeah,
multiplication.
Repeated multiplication, so a multiplicative rate of change, right? But as a quick reminder, because this can help you, what is the name of a multiplicative rate of change? Common ratio.
She knows everything.
Think about how we calculate that common ratio here. But two things I want you to remember. Is a multiplicative rate of change all you need to write this equation?
No.
No, what else do you need?
And justification.
Well, as part of calculating that, yes, but there's something else you need besides the rate of change.
A form.
A y-intercept?
Maybe that's one type.
A point slope.
Start.
You have to have a starting point. It does not have to be the y-intercept, but you do need some kind of starting point. That's important for both a recursive and an explicit.
Ew. There's boogers all over my hands.
Okay, that's a little gross, I'm sorry. Alright. Can anyone see what the rate of change is for this function
Yeah.
in the graphical representation?
Oh, no.
What do you think it is, Carell?
1 up. Oh,
Ew.
So 1 up, 1 to the left.
1 over 1.
So I want you to think about that though. That is called, that when you calculate rise and run, you're trying to calculate the what?
Slope.
Is that a common ratio?
No.
So you can't just do rise and run, because notice that changes here,
Yeah, it does.
right?
It
So
does.
it's not a slope. We can't just look at rise and run here.
Okay.
It's not even up one. It's
Thank
up
you. It's
two.
not up 2. It's not up 1. It is up 2. You have to pay attention to the scale. To get to
I
10,
said that.
you did not, you liar.
I said up 2 first, and I changed my answer to 1, so I was wrong.
So you were
So
wrong.
what could we make instead to make sense of the rate of change?
Look at the table.
Look at a table. We can make a table.
Yeah, I did that.
I thought we got table. Oh, that's number 2. I'm tripping.
Mine is 2, 4, 1, 6, 0, 9.
2, 4,
Yeah,
1, 6,
yeah.
and 0, 9.
And 1, oh, I don't know the one.
Yeah, we don't know that other one. And
No,
it would
it's
be
hard.
-1, but we can't really quite tell what that is, so we don't think about it. But use this table to find your starting point, to find your common ratio.
Oh my god.
Does that help?
Ew, nasty.
Okay, looking at number 2, cannot tell you how many students today have told me, hey, Mr. Kenny, it's adding 7.5. And I said, you know what, you are so correct. And then I asked them, hey, what's the slope? And you know what they told me?
What, 3?
What?
They told me the slope is 7.5.
I put
Ah,
7.5
dang it.
over 5.
Thank you.
Yeah.
Where did you get that 5 from?
The other side?
The other side.
Wow.
Because when we're talking about the y values, we're only talking about the
The
rise. Is the rise the only part of the slope that we need to consider though?
rise.
Run.
No.
You have to run,
We
though.
also need the run.
Yeah, I'm so smart.
You have learned well.
Because of my teacher.
Because you work hard.
Stuck up.
Because I carry this class.
That's it. She carries the class, don't
So what's
forget it.
1.5 then? That's part of the slope.
What's 7.5 divided by 5?
Yeah, I know it's 1.5. I'm saying this part is.
Oh,
It's not part of the
I mean part of the rate of change.
It's not part of the rate of change.
What is?
It is the rate of change.
Oh.
M is my slope, right? We
Yes.
calculate as rise divided by run,
Uh-huh.
and 7.5 divided by 5 is 1.5. That is my slope,
Oh.
okay?
So 7.5 and 5 is the y and the x.
Well, the 7.5 is the rise in the y, the 5 is the run in the x,
Oh, okay.
but you still need a starting point, right?
Yes, sir.
We should know lots of explicit equations we could use here. It's your choice which one you want to use.
Mr. Liphair needs to come back.
Unfortunately, he won't,
He's a goat.
okay?
I miss his presence.
Let's look at today's objectives, the S task, and looking ahead. Does anyone not already have a copy of this S task? I think all of us were here last week, right?
Yes, I have that.
I wasn't here last week.
Yes, you were.
I took out.
You were here last Friday.
Yes, you were, Krill.
Bro, why is it flying?
I need one to skin.
Pop that
Brill,
up.
if you had this half sheet, you have the S pattern task, and that's how I know you were here.
Yeah, pop
Good
that
job
up.
at lying poorly.
I got you.
All right, we're gonna model with mathematics, SMP4, and look for make use of structure to do what thing, Layla?
Oh my gosh, that hurt my shoulder.
Layla, what's our objective today?
She got shotgun shell.
Oh yeah, sorry, let me get it quick. To make sense of a quadratic relationship. This is our last task before our test. I've intentionally modified this task to get us better prepared for the test that we have on Wednesday. Tomorrow we're going to go over the task as a whole class, and we are going to go over the understanding check from last week. So we need to work efficiently today.
Cool.
Okay, Corral, I'll come answer your question in a
This
second.
Wednesday?
Huh?
This Wednesday?
Yes, dude. It was supposed to be last Friday.
Shelby, give me your jacket.
Okay,
I don't have anything underneath it.
really quickly.
I know.
Hey, please stop talking and listen.
Okay, sorry.
Please notice in number 1 it says, what patterns do you notice in the set of figures?
I know.
I know.
Then y'all talk about it in your
We
group.
did figure it out, remember?
I know.
Yeah.
Now, y'all talk about it in your group though. I want you to pay attention. Remember, pay attention to how the figures are growing, what you see changing, and more importantly, how you see that change connect to the figure number, right? See how it connects to the figure number, because you're going to have to describe a figure in the sequence that is larger than the 20th figure without drawing it. You've got to be able to describe it.
Wait, what?
What do you mean what?
You said what again?
Number 3, describe a figure in the sequence that is larger than the 20th figure without drawing it.
Wouldn't 21 be larger than that?
Huh?
Wouldn't the 21 figure be larger than that?
Sure, then go with 21 if you want.
I thought everything
Yeah.
above 21 would be larger than 20.
Yeah. Have you described what that 21st figure looks like though?
No. Oh yes, I
It
know.
looks like it.
We know.
Okay, but that's my point. We're trying to describe what that figure looks like.
We
All right.
just say it looks like this.
Say again.
You have no
That looks like